Hello everyone, NNNI here, and I've waited the whole week to make this video. I've come up with the stuff on Monday and I have to wait till Thursday because the YouTube editor is no longer available and I had to download the Windows Movie Maker and install a few required fonts on it. So finally I've gotten back to uploading proper videos again, and as usual I got bored in school and I came up with a few new innovations, if you will, for railguns. So first things first, this is a translation from my school notebook because everything there was just scribbles. So first I drew this, a 5mm square bore, because I'd seen one of these railgun designs that used a square bore and I thought, why not? Seems like a good idea. And then after a lot more thinking, I came up with these features that I can add to my railgun. A brushed projectile. The first thing that came to my head when I thought of square bore, because brushes seem to be the only way to go after this to get maximum efficiency than having a solid projectile. So I just get myself some copper, wind it onto a piece of something and shoot it. Improves efficiency a lot. I'll link in two videos in the description that use brushed projectiles. Actually, one video and one link. Both of those links are in German, unfortunately. But still, the results seen are quite amazing. And then how about a variable magnetic field? Now the way I was going to implement that was a bit complicated, but here it is. It's a rough sketch of a rail design which I'm going to be building now. I've changed my old design. I'm no longer using a 2mm graphite rod. So these are two threaded rods. This is the front view, obviously, so there's 4 rods in each corner. So these diagonal lined rectangles are the copper rails, and these are acrylic supports on top and bottom and the sides of the rails, and these are the magnets, these small highlighted portions. And the way the magnetic field can be varied is by moving these two magnet plates, if you will, up and down along this threaded rod. So that gives you a lot of flexibility over what you want to do with the magnets, or remove them altogether if you don't want them. And that simplifies the construction quite a bit. And now these rails, they have slots. This is the new rail design that fit into holes on this top and bottom acrylic plate, if you get what I mean. So they are quite easily replaceable, and this, by having a rather long slot, gives me more flexibility to be able to test multi-turn rail designs. So I can just put 2 of them alongside each other and they just fit into the same groove and screw everything together using these threaded rods. So that's what I came up with. Should be quite interesting to test out. And then the projectile, maybe an acrylic cone with copper brushes. Now the way I'm going to make these brushes, hopefully, is have a spool and wind a 2mm by 4mm ring of copper, cut it, spread it out, and then bend it and sand the sides, actually not the ends, and slip it into the rails and then fire. And now that I can't have an injection system because of the brush projectile, I need an SCR bank, and I'm planning to use 10 TYN 612s, I think, which can handle 130 amps pulsed. So I put 10 of them in parallel, so 1.3 kiloamps, which is quite decent. And graphite lubricant for the rails and coating the rails with solder. I'm not very sure about this since it increases resistivity a lot, but the only advantage of this method is we can continuously keep resurfacing the rails instead of having to replace them due to damage. And I have 2 examples here. This is just bits of copper, 3mm copper, that I intend to use for the rails. My drawing's a bit thicker than the real life thing. Anyways, okay. So I coated these two with solder. This was my first attempt, a very thick layer of solder, as you can see. Not the best soldering job. I didn't get the smooth even finish I was hoping for, so I tried to make a thinner coat by applying a lot of solder then wicking most of it off. But my only problem with this one is that the layer might be too thin, but anything that prevents contact arcing is good. And I've also coated it with some graphite. It rubs off on my finger here, if you can see the dark thing. I just scratch this with a pencil. So this is what I might be doing for the rails. So these are the innovations I've come up with for now. And one more thing, I came up with this circuit for the trigger mechanism, which I've built into this 3-in-1 board, protection board if you will. Discharge, fuse blown indicator, and now this trigger circuit. So what this does is it takes the battery voltage and regulates it to 5 volts. That is if this jumper is left unconnected. So you have 5 volts out. Well, due to this diode, not exactly 5 volts, more like 4.3 depending on the voltage drop, and a 4.7 microfarad capacitor. Now if I'm using an SCR bank, I can use this 5 volt setting so that I don't overload the gate of the SCRs and then the trigger button here. But if I'm using something like a solenoid or some other injection mechanism that requires a rather high current, I can always bypass this regulator using this jumper. The reason I added this diode is so that when I have the jumper shorted out here, the 12 volts doesn't go back into the regulator and fry it. I've tested this circuit and it works perfectly. Sorry, no troubles over there. So this is all the things I've come up with. Let's see if I can put this in practice. Thank you for watching.